nearly 2 o'clock. Hello and welcome to Cool Kids' Way of Generating Code. Obviously, I decided to take a title that sounds fancy, but code generators are not that fancy anymore. I mean, another talk about code generators, really? I mean, it's a very old thing and nobody cares. But what is a code generator actually? I mean, at the end you have an AST on the left-hand side, and then you have a generator in the middle, whatever that is, and on the right-hand side you will end up with text. That is, in most of the cases, configuration files or source code. And then you might claim, no, we don't do model-to-text generation, we do model-to-model-to-model generation. Yeah, but at the end you might want to do this one, generate code. So in this talk, we will, I would like to share you an adventure through the time of code generators. I mean, there were various languages for doing the job, and I would like to first go through the languages that we currently have. I mean, if we consult Google and ask him, what do you know about code generators? And we get more than 8 million hits. And there is a lot of stuff in code generators. The idea is very old. And what's out there? So some people do that with Java, of course. You can do that. You will end up with source code that might look like this. Yeah, it's very loud. You have to write a lot of code. And will work, will be fast. Why not? Why not using Java? Then there are other techniques like this one is from Java as well. I mean, the problem is you can write it in Java, but it reads very ugly. So because you don't really see where there is a line break. I mean, you can see that backspace n, yes, but it would be much nicer to have some kind of template languages. And in the dark years, we had a template language named Velocity. Who remembers Velocity? Yes, very nice thing, yeah? I mean, there was at least editor support for that, a bit editor support, not so much. But the problem about template languages like Velocity is, on the left-hand side, you see the template, and it uses things like here you can see there is something reference utility, and that utility is defined down there as a string. So there is something that is put into the context, and in the template itself you can dig it out by using a string. How ugly is that? Nobody will do that nowadays. Next thing is looking at the template itself. You can not decide if something doesn't go into the generated code or not. So you have to make a deal with yourself if you want to write a template that is readable, and then you will have ugly code, or you will decide to write nice a template in the way then the code looks nice, but then the template is unreadable. So in this case, there are other technologies out there nowadays to do the job. And Excelio, who knows Excelio? Yeah, not so much, but a lot of people in the audience. I mean, Excelio is very cool because the tooling that you get with Excelio is great. But Excelio has the same problem than Velocity. Everything that is written there goes into the text file, and then you end up in something like that. On the left-hand side, you see you have indentation at certain places, and those indentations are there to make the template read good, but the code that's actually generated doesn't look good because indentation at the beginning of the class, come on. Then we have other template languages like Jet. Who knows Jet? Yeah, and where's Jet mostly used? In EMF. So normally nobody changes those templates. At least there is editor support for that. But looking at it, you reference things by strings. not better than all the other things that we have seen so far. And then there was one funny thing that I saw in Google. I've never heard about that. And last week I came across that. It's T4. Who has ever heard about T4? Nobody. I expected that. I mean, it's a template language for generating code, and I'm doing code generation since 10 years, and I've never heard about it. And I don't know if there is good support for the template language in Visual Studio, but I guess. But it still has the same problem. Everything that you see goes into the code. Same problem. Then we have expand. Who knows expand? It's we use that under Xtext for a lot of years. Expand has the same problem as all the other template languages that we have seen so far. Everything goes into the file, and because of that, we have introduced special things that those lines that actually do iteration and all that, they will not go into the file when you write something like the minus at the end. I mean, we can do that, but we can do better. And for expand, there are a lot of things that you can't do in expand. Because of that, you do it in Java, and for that, expand has support for extensions. Those extensions are classes that have a bunch of static methods. You can call them within expand. That's really slow. I mean, most of the languages that we have seen so far are interpreted, and they are not really fast. And you need a lot of stuff to actually build the context so that you can run that code generator. Okay, all of that is old, and the title of the talk is what the cool kids do. I mean, what they do JavaScript. Most of the cool kids do that. And when you ask Google about JavaScript code generators, you get 1.29 million hits, and I try to dig out some examples. This is actually a code generator written with a Node module named JS Code Generator, and it's more or less for model-to-model transformation. There you can have whatever data structure you have, and you transform that with a special API into JavaScript. Okay, that's one use case for generating JavaScript. What about other things? There are Node modules for generating TypeScript as well. I mean, TypeScript is an abstraction over JavaScript. Very nice language, by the way. And there you have support for doing model-to-model transformation as well. And then there was something that I came across as named Telosys. Who's heard of that? Nobody. Actually, it's an Eclipse integration for Telosys, an editor. And Telosys has a bunch of templates on GitHub that you can use to generate stuff out of your relational database schema. So you do not really have to define a meta model or something like that. The only thing that you have to do is you have to have a database, and with the templates that Telosys is supporting, you can generate fancy architectures for accessing your data in the database. I mean, there are a bunch of templates there, but there is no editor for that. I mean, no good editor. There is support for Eclipse, but not really good. So that could not be the stuff that the cool kids are using. When I tried to consult Google again about JavaScript template and generate, I got 248 million hits. And it's very hard to get out of those results something meaningful. I mean, I've seen that somebody is able to write a code generator, and that is everything he has written in JavaScript to get a so-called template language. And what you see up there is a template language that is completely defined in this kind of code, but there is no editor support, of course. You can generate code with that, but you don't want to. And I think the problem that we can't find something really good in the JavaScript world is because the cool kids think code generators are for all people. I mean, nowadays, when you look at frameworks in the JavaScript world, they claim you don't need to generate code. Why the hell would you do that? And there are various articles that claim that code generators are dead. I mean, code generators are dead? Seriously? What about TypeScript? I mean, TypeScript is more or less a cool thing. They like TypeScript a lot because they have JavaScript support and they have a type system, and that's cool. But at the end, what about the transpilers from from TypeScript to JavaScript? There is a code-to-code generator, or so to say, a model-to-text generator, and we do the very same thing in our infrastructure in Eclipse as well, as we have extend. Who knows extend? A lot of people. I mean, in extend, we generate Java. And we do that by using Xbase. Who knows Xbase? Okay. I just want to go through some core principles of Xbase and then come back to code generators, because Xbase is a very nice way of having expression language library with all the support that you need for expressions and a compiler that is actually code generator. So as nobody wants to do everything on their own, we have that common JVM type model. That is a model where we have everything implemented in the backend. So we have scoping, validation, generator, and all that. I said we have a typing system and we have a compiler and all that. And the only thing you have to do is you have to transform your special concepts out of your DSL to concepts of the common JVM type model. And when you do that, you have the possibility first to reference things out of the Java world. And if you transfer your concepts to the JVM model, we call that the derived Java types, then you have bidirectional references from Java to your concepts and the other way around. And at the end, you can generate Java out of that. And you gain a lot of things like a very complex type system that can do everything that Java can do, that can deal with Java. You can directly reference Java and all that, and you get a compiler, and the compiler will compile something that is actually debuggable in Eclipse, and that's pretty cool. I mean, we'll come back to that later, but first come back to code generators in general. Who has ever heard about MPS? Yeah, MPS is meta programming system from JetBrains, a very cool idea. And to make it very, very simple, in MPS you have DSLs. In that DSLs you describe concepts, and those concepts are more or less mapped to a target language. That target language can be Java, can be C, or whatever you prefer or is there. In MPS itself there is C and there is Java, and that comes out of the box. Sometimes you have to install extra plugins like Embedder and all that. But yeah, the core principle is that you have to transform your things into the target language. And that could be Java. And the mapping is done in so-called reduction rules. In MPS, you don't do model-to-text transformations normally. You can do that, but as long as you can, you have to stay in a model-to-model transformation. So you transfer your concepts to another concept of your target language, and then Java can, the language Java itself that is implemented in MPS can use your concepts so that you can mix languages. That will not work with things like Xtext and all the other technologies that we have. In MPS, you can say my concept maps to a Java concept like method, and then automatically in the Java language in MPS itself, you can treat your special concepts with the editor that you are supporting for your language within Java itself. So there is no boundary between languages anymore, and you have to restrict that if you want. But coming back to code generators, reduction rules, that is how they look like. I mean, you define what is the concept that you want to generate or map something from to another concept of the target language. And the cool thing about that is you don't have to instantiate in AST or all that. You just write the code that you mean in the target language, and then you exchange some of the parts. So here we have a variable declaration, and then we say there is, as an example, int is the type of the variable declaration. Then it has a name, and then it has some kind of expression. And in the next step, you do something like, here are placeholders. In this case, it's an example. The type is int. And then within the copy source thing here, in an editor, I have to admit that you have to open up. You will see that you can fill in the gap. So in this case, it's the type of an initializer. Next would be the name of the thing that you just have that you want to map. And the next thing would be the initializer itself. So it's a completely different way of writing so-called code generators. Reduction rules are very powerful. I mean, you can write something like that. Actually, that is C. This is a C function, and within that, I can use the things that I've done in my DSL. And as for every single concept of your language, there is an editor and there is a code generator in a reduction rule, so that you can mix those languages together, and that's pretty cool. I mean, it's more or less this, not really the same idea as XBase, but it can do more, and it has more target languages. XBase can only deal with Java, but the idea is the same. And of course, you cannot mix languages with XBase. But coming back to that, I said in XBase itself, you have the same story. You transfer your concept into the derived Java types, and then you end up with something that will work out of the box because we have compilers and all that. But how is that done? I mean, that's done with extend. That sounds weird. I mean, I have extend, and extend is based on XBase, and XBase is based on extend. And the code generator within XBase is written with extend, so that's bootstrapping. And at the end, everything is written with Xtext. And coming back to extend, we're talking about code generators, and what do the cool things? What are the cool things? I mean, let's see what extend can do for us. It feels a bit like Java. It compiles to Java, but it can do more. And it can do even more than XBase. So we have the template expressions. And within that, with this good beamer, you can see the gray space. Here you see that's the declaration of a method, def. And then you have that, in this way you declare a template expression. And then you can have control structures like looping, like this one. You can loop over things in your meta model or your list, and then you can generate things. And those gray spaces that are shown there, they you can see what goes into the file that gets generated and what not. So that's a big difference between all the other languages that we have seen so far. And you see that the control structures like this one here, the for loop, will not go into the file. There's no gray space. And here you see there is a gap in between. So there is an indentation that the template reads good, but nothing of that goes into the file. And that's the core idea of that. And another cool thing about that is if you have a call to another function that maybe has an indentation or not, it takes the old indentation that is already there, this one here, into account. So it knows where to put that. And even if it is a multi-line template expression, of course that works. So that is the core feature of extend. But beside that, we have other things like model navigation. So if we would have a comma-separated list of names of abstract classes, we can say in EMF itself, you can console the package, then the classifiers, and then filter. And that filter function comes with XBase, and at the end, it's in extend. And it's very easy to do that. After that, you can filter So here we have brackets. Within that bracket, we have access to the objects that are inside of that list. And in this case, it's more or less the call to a function that is named isAbstract. And after that, we can have map. A map, within map, you have access to the objects that are inside of the list. And whatever the return type of the expression that is inside here is, will be mapped to a new list that will be returned. And then you have here at the end, I hate that. Who cares? I mean, you have a lot of extension methods that you can use: map, sort by, filter, and you can create your own one. And there it comes to extensions. Extensions, you can create API at places where you really need it. The difference to Java is they feel like they would be members of the objects that you are currently dealing with. Let me give an example. Here you have an extension named primary key and an extension named type name. Primary key wants to have an entity and the other one an attribute. If we use that, we have to say it's an import of a static thing, and when we do that, we can write it like this, like in Java. You can write type name within that primary key, and because the return type of primary key is an attribute, that becomes the parameter of type name, but that reads from inside out. I mean, the control flow is the other way around, and it should be better to do it in this way: entity.primaryKey.typename, and that is doable with extend. And the only thing that you have to do is write that keyword there, extension, and then extend makes that possible. And then it feels like primary key would be a method of the entity itself. And that's very sexy when you write code generators. I've done that. Then we come to dynamic dispatching. Dynamic dispatching, you write a lot of methods, and normally when you do that in Java, you have to write if statements. If it is instance of this and that, go this way or that way. And you have to do a cast and all that. In extent, you don't have to do that. You just call the method, and it will consult the corresponding method that fits for that type. So here we have 3 dispatches for apple, orange, and kiwi. And with whatever fruit we consult that generate method, it will call it. And in the back, extend will generate a Java method that has all that if statements inside for checking if it is instance of or not. And it will do the typecast for you. Then we have dynamic dispatching for switch case expressions. The normal expression in Java can't do that. In extend, we can. Whatever object you have, you can put that in. And then you have several ways of dealing with those objects. One is you can directly install a type guard. In this case, it's an apple. And you end up then in a result. Same thing for the normal case, that you can access the fruit itself. And what is cool is whenever you have a so-called type guard, like this orange, and in the case itself that you can add in addition, you have access to all the methods within orange without doing casting. So extend will do that for you. That is not the only place where extend will do that for you. So writing code generator with extend is very, very easy compared to all the other technologies that we have seen so far. There is IDE support. I don't want to go through the whole list, but you get the idea. You have everything that you normally want for programming languages within Eclipse, and in addition, as I said, with Xbase, there comes debugging. So whenever you have your Xbase model or your language that inherits from Xbase, and you did that mapping from your concept to the derived common Java type thing, whenever you did that, and there is the compiler of Xbase will install then maps that map from your resource object, your source object, to the target object, and then at the end to the corresponding Java areas that got generated. And then you have things like that. In this case, this is just a Java class that I can invoke. Then it stops in the Java class, of course. And after that, if you go further, then you can see it stops in the corresponding template. And then you can decide to not debug extend anymore. Instead of that, doing that with Java, that's possible. Then you can go further, and whenever you want, you can decide to switch back. And then we are back into extend, and we can see that we have all the way debugging support for all that, and that works for all Xbase languages. And then you, of course, in the debug view, you can see you have access to all the fields and all that. So that's pretty cool. I mean, you have a code generator that you can actually debug, and you don't have to build such a big context to invoke the code generator. The only thing is that you can treat it like Java in the very same way, and it is, once it is compiled, it is as fast as Java, and that's pretty cool. In addition, you don't have to, but you can do modularization when you want it, and we do that a lot. We use dependency injection for that, in most of the cases Google Juice, and then writing code generators that have several parts that you can exchange for several reasons. You end up with a very good framework that you can use for generating code nowadays. You don't need an engine, you don't need context objects that we have seen in all the other examples, and it feels like Java, but it's even better because of the rich strings. So, coming back to the story that I told at the beginning, what do the cool kids do nowadays? As we have learned, the JavaScript universe doesn't really use code generators so often. They have model-to-model transformations from time to time, but digging into the results of Google do not really bring good results that the cool kids nowadays are using code generators. But I think the idea of code generators is still not dead. I mean, the frameworks got more powerful and you don't have to write so much boilerplate code nowadays. But still, if you want to generate your code because of the story that you would like to do modeling, because of the fact that you would like to conservate your ideas about your whole system without having dependency to the concrete technology, that works still very, very good. And with Extend, you have a very good language for creating code generators. With Xbase, you have a rich library for expressions that comes with compilers, debugging, and all that support that you want. And with MPS, nowadays, you have the possibility to do projectional editing. Who does not know what projectional editors are? Some projectional editors that we create with MPS are a bit different to graphical editors that we are used to in the Eclipse universe, and they're completely different to textual editors because of the fact that you normally don't interact with the AST direct with the text directly or with the graphic directly. Instead of that, you interact with the AST itself, and you can you can do several things with that, like showing the very same AST in a very different way for different clients. And you can do things like mixing notations like graphical with textual without quirks and all that. That works fabulous with MPS, but MPS is still a fat client. I mean, at the end I could say that, or I will say that code generators are still very popular, I think, and there is still a place for code generators. And to round that up, maybe it's not the cool kids stuff, but it's more or less for adults. And I think in Eclipse, we have a very good community for modeling still, and we have one of the best template languages out there to write code generators. By the way, I would not really suggest to write everything with extend, because the step in the middle for transferring or to generate Java code out of extend and all that calculation of types, that's very expensive. And for code generators, that's completely super, but maybe not for everything. And saying that, I'm open for questions. No questions. Who is a JavaScript developer here in the room? Yeah? Is there something that you use for generating code? Yeah, I know. Yes, Nico. No, I haven't. The question was if I know what is the implementation of the transpilers between TypeScript and JavaScript. To be honest, I don't know, and it's not so easy to look inside the internals of that. But I guess it's an internal template language of Microsoft, something like that. No, hopefully not. Another question. Okay, thanks. Yeah, there's one question. So the question was, when you have the case that you want to generate different artifacts for the very same object, what do you do? There are several ways of doing that. There is the text way of generating things. So you have an API where you get access to resource, and within the resource you have the file system access for generating different files. And one file could be a Java file and the other one could be a C file. So there is API for that. And of course, if you are outside of Xtext, you can use extend as well. And then you have the possibility to grab that string that extend is creating for you and put that into whatever, in a file or whatever you want to do with that. So there is already API for doing that. What could be a problem, and some people, we have several block entries that they claim that they want to generate configuration files for a bunch of things, so that you don't have a 1-to-n relationship from source object to several things that you want to generate, but the other way around. Answer for that is, in Xtext there is no direct support for doing that, but as extend itself just produces strings, you can of course do that. And the Maven and Gradle plugins that we have for extend, they don't have support for that. But what you could do is you could try to merge things when there are changes. I mean, that's not so easy to implement, but maybe it's very easy to just use extend and establish your own way of generating code. You can reuse all the stuff that comes with Xtext. You don't have to. There's one question. The code generator, the question was, I mentioned that maybe for Xbase, it's the case that we do a model-to-model transformation up front, and then we have a code generator in the back, and that people claim that a code generator should not be aware of what? Sorry. So the question itself was what I said already, but in addition, that a code generator should not contain complex logic. For the XBase compiler that we have behind XBase, of course, there is complex logic in between, and doing the model transformation with XBase is more complicated than just writing your own code generator. And maybe then that's true. Yes, it's more complicated, but at the end you gain a lot from that because you don't have to write it on your own. And you have everything that we learned over years about expressions and all that, how to treat that. You get a code generator that can handle all that cases already. And it will be complicated, of course, but it's not designed to be changed. Normally you deal with the concept that comes with XBase, and there is API for doing the model-to-model transformation, so that's not that hard. Getting the first idea why you do that and why you should put expressions into context and all that, and what you gain from that, that is really far more complicated than the rest. Does that answer the question? Okay. Thanks for being here. See you around. I have a next talk tomorrow with Fabio about machine learning formatting tomorrow, and really cool stuff. We did that last year as well, but nowadays we have more things in addition that we want to present to you. Thank you.